Dear friends, welcome to the next session for software engineering and designing concepts. In today's session, we will first look at the various software categories, followed by the various characteristics and attributes of a good software. We will also look at the challenges that are faced during the software engineering phase, and finally, we will look at the differences between the exploratory style of development as compared to modern software engineering techniques. So let's get started. To begin with, softwares can be classified into three different categories. The first one being system software, which are basically collection of programs that are written to service other programs. They have multiple users and are characterized by heavy interaction with computer hardware. They need extensive scheduling and resource sharing and sophisticated process management when it comes to concurrent operation of various components and applications. They use complex data structures and has multiple external interfaces that would be used for multiple functionalities. For example, compilers, operating system, device drivers, etc. The second important category is application software, which are basically standalone programs which solve a specific business need or purpose. It is used to control business function in real time. For example, word processing software, media player, etc. The third and the final category is engineering or scientific software. They are generally characterized by number crunching algorithms, and almost everything which is related to engineering or scientific domain can be solved using these scientific or engineering softwares. Applications which deals with astronomy to volcanology, automotive stress analysis to space shuttle orbital dynamics, and from molecular biology to automated manufacturing. Almost all possible engineering solutions are given through this engineering or scientific softwares. That is, they can be simulated using these softwares and effective results could be analyzed and executed. For example, computer aided design or system simulation, etc. So moving ahead, we will now look at the various software characteristics. Generally, it is said that a software is developed or engineered and it is not manufactured. It does not wear out, but definitely it deteriorates. Software continues to be custom built as industry is moving towards component based construction, and more demand are rising for custom made application, that is whatever the user wants, only with those features or modification of the existing software with the user required features is basically done. It is said that software does not wear out, which means that it is never out of use, or it is the situation never arises where that software will never be used, but definitely it will deteriorate, and whenever it deteriorates, some more improvisations on that particular software will be done so that the software continues to be put to use, but with a different version and with more advanced features and technology. We will now look at various attributes of a good software. Generally, a good software should be maintainable, dependable, and usable. It should also be efficient from the perspective of cost and system resources. The software should deliver the required functionality and performance to the user within the definite or the required amount of time, and should be robust enough to withstand any type of problems that might be there related to the resources or data. So the first important attribute of a good software is maintainability which means that the software should be scalable and should evolve to meet the changing needs. Whenever a user wants to incorporate any changes, the software should be able to accept it. The next important attribute of a good software is dependability, which means the software must be trustworthy and should be accurate while performing the functionalities. The third important attribute is efficiency. It should not make wasteful use of system resources, or it should not waste the system resources, and should be carefully and logically utilizing the available resources with minimum expenditure. The fourth important attribute of a good software is usability. The software must be usable by the users for which it is designed. Simply building a software which is so complex that the user might not find it easy to use will not be termed as a good software. Instead, it will be a problem for the user after it is developed. So, what are the key challenges facing software engineering? Basically, coping with legacy systems and increasing diversity, as well as the demands for reduced delivery times, forms the key challenges to software engineering. Talking about legacy systems, it means old and valuable systems must be maintained and updated. On doing this, that means on maintaining these old and valuable systems, a huge amount of space and a huge amount of resource as well as cost is involved. So hence it is extremely important to plan which system should be stored and which system should be discarded is of extreme importance. The next challenge is heterogeneity, which is also known as increasing diversity. Since systems are distributed, it includes a mixture of hardware and software. So sometimes it becomes difficult for different systems to work in sync with each other. The third important and one of the most difficult challenges is delivery, which is increasing pressure for faster delivery of the software. Generally, whenever the users or whenever the clients request the team of developers or gives out a contract to the team of developers to develop a software, they fix a deadline for submission of that software. Usually it is seen as per statistics, the users or the client, instead, in spite of setting up a deadline, they demand the work to be done at an earlier date, which unnecessarily builds up pressure and stress for the developers for developing that particular software, and it might also lead to poor quality software development. Along with the challenges, there are certain professional and ethical responsibility associated with each of the software that is being developed. Simply application of technical skills does not suffice software development, but engineers must also behave in an honest and ethically responsible way if they are to be respected as professionals. So, what can be the issues for professional responsibility? First important factor is confidentiality. Generally, engineers should respect the confidentiality of their employers, and even though they have signed a formal confidentiality agreement or not, they should be loyal to their employers and loyal to their client. The next important issue related to professional responsibility is competence. The developers or the engineers should not overestimate their level of competence. They should not knowingly accept work which is outside their competence. Suppose a developer is well versed with development in Java, so he should strictly adhere to his competency level rather than digging into a domain and claiming himself as an expert in that domain related to which he has no professional training or no professional experience. The third important factor is intellectual property rights. The developers or the engineers should be aware of the local laws governing the use of intellectual property, which includes patents, copyrights, etc. And they should be careful enough to use these properties of the employers or the clients which are protected. The fourth and one of the most important issue is computer misuse. The engineers should not use their technical skills to misuse other people's computers. Misusing other people's computers may be ranging from as trivial activities like playing a game in someone else's machine to sending viruses across using someone else's machine. Now, we will discuss about the evolution of some other software engineering techniques apart from the already existing ones which we have discussed in our previous lecture. Software engineering techniques began with exploratory style of development or the ad hoc style of development, followed by structured programming, data flow oriented programming, object oriented programming, etc. Now, apart from the already existing ones, the software engineering techniques has evolved to some other domain as well, which includes life cycle models, specification techniques, project management techniques, testing techniques, debugging techniques, quality assurance techniques, software measurement techniques, case tools, etc. So all these software engineering techniques along with the current design paradigm, which is the object oriented programming paradigm, forms the basis of the software engineering techniques. So hence all these points that are shown in this slide will be discussed in detail in the subsequent sessions so that we have a good grasp about the knowledge regarding the evolution of software engineering and the various techniques associated with it. So now let us move on to the differences between exploratory style and modern software development practices. Exploratory style, as we have already discussed in our previous sessions, included intuition as its backbone for software development. Exploratory style essentially was also known as ad hoc style of development and generally explored into areas which strictly involve intuition of the human cognitive mind. However, there are certain differences related to exploratory style of development and the modern software development practices. The first difference is use of life cycle models. Life cycle model we will be discussing in our subsequent sessions. However, we have to know that software is developed through several well-defined stages, and these well-defined stages are collectively known as a life cycle model. These stages includes requirement analysis and specification, design, coding, testing, etc. Together these steps forms a life cycle model, and modern software development practices makes extensive use of lifecycle models. The next important difference is the emphasis with which both the techniques work. The emphasis has shifted from error correction to error prevention. As already discussed in the previous sessions, exploratory style of development involved build and fix style in order to develop a software. However, modern software development involves detecting the error as close to their point of introduction as possible in each phase, and the bugs are solved then and there before proceeding to the next phase. While in exploratory phase or exploratory development, errors are detected only during the testing phase. The third important difference is the development paradigm. In exploratory style of development, coding was synonymous with program development. That means if someone is asked to develop a program, it means he is asked to code the problem or code the program. Whereas in today's concept of software engineering, coding is considered as only a small part of the full program development effort, which also includes requirement analysis, designing, testing, maintenance, etc. The fourth important point is standard design techniques which are used now. A lot of effort and attention is currently being paid to requirement specification, and standard design techniques are being used. As and when the sessions progresses, you will notice that there are a wide range of designs or software engineering designing concepts which the developers or the engineers use in order to develop a particular software. Moreover, requirement specification, which in the form of an SRS, is generated so that the users or the clients and the developers can have a clear idea of what they are going to develop and what is going to be delivered. The fifth important difference is during all stages of development process, periodic reviews are being carried out in modern software development techniques. These periodic reviews not only enables the manager or the team to keep up with any of the deadline oriented issues or any of the resource oriented issues. However, it also keeps a check on the cost as well as other project management parameters. The sixth important difference is standard testing techniques are available. The current scenario represents various testing techniques which are available to a wide number of users for testing before it is finally released or finally delivered to the client. For example, alpha testing, beta testing, etc. So testing by friendly customers or friends and testing by close acquaintances or close group of users forms the basis of testing techniques, and once the feedback is generated from them, it is finally sent to test or put to test by the client themselves. And finally, after all the testing is done, it is ready to be delivered to the client. The seventh difference lies in the visibility of design and code. Visibility means production of good quality, consistent and standard document which leads to smoother fault diagnosis and maintenance. So generally, the current software engineering paradigm involves extensive documentation so that whoever is being handed that software to gets a clear idea of the usage, the development, and the issues that might be related to the software. Without documentation and proper user manual, the software development is incomplete. The 8 important differences: the projects are being thoroughly planned in modern day scenario where estimation related to cost, manpower, and resources is calculated, followed by scheduling, which involves the scheduling of various activities and the time that at which point they will be completing it. And third important planning is monitoring mechanisms, where the group leader or the manager has the authority to keep a check on the development process. Lastly, usage of computer aided software engineering tools is widely seen in the modern software development paradigm, where standard techniques, tools, and methodologies which are already defined and implemented are used for the development of softwares. So that is all for today. In the next session, we will be going through some more interesting concepts related to software engineering paradigm. Thank you.